In this video, we're going to look at a special type of surface called a cylinder. Cylinders in R3 still have the equation f of xyz equals 0, but only two variables show up in the equation. So let's check the three things that happen with cylinders. One, equations are in R3, but only contain two variables. These will result in cylinders. We'll talk more about that in a moment. So two variables. The cylinders are directed along the axis of the missing variable. And one more thing happens with cylinders is that their traces do not change along that axis. Let's look at an example to make sense of these three properties of cylinders. So our first example, we want to sketch y equals x squared minus 4. Now, if this were a two-dimensional equation, then we know this is just a parabola on the xy plane. In terms of 3 dimensions, notice first that the variable z is missing, which means that this cylinder will be directed along the z-axis. So that's the second point above. It's directed along the axis of the missing variable. So here it will be directed along the z-axis. The trace that will remain the same is the trace that's on the xy plane, and that will get repeated along the z-axis. So the trace will not change, of the parabola will not change along the z-axis. So the trace is a parabola because y equals x squared minus 4 is a parabola. And that will not change along the z-axis. Let's write that down. What's happening here is that we're specifying a rule between x and y, but z can be, because it's not there, we can assume that z can take on any values from negative infinity to infinity. That's the missing variable. So I'm going to do a very tiny sketch on the side here, and then I'm going to show you on Calplot 3D what this cylinder looks like. So if we, just on the right here, I'm going to put the x-axis coming towards us. Here's the y-axis and the z-axis. And I'm going to sketch this parabola on the xy plane. So this parabola is y equals x squared minus 4. That means we've shifted 4 units along the negative y-axis, and on the xy plane we have a parabola that looks something like this. So imagine that that's just sitting on the xy plane, and z here is 0. But when z is 1, right, we move up 1 unit and we have the same trace. And when z is 2, we can move up 1 unit and we have the same trace. This is what we mean by the trace not changing no matter what value z takes on. And so as z goes from negative infinity to infinity, we create something that we call a cylinder. This is a parabolic cylinder directed along the z-axis where the trace is a parabola, and that parabola does not change as z takes on different values. So I've also sketched it below. I went to Calplot 3D, and you can do the same, and I'm just going to point to a few things. I've entered in the equation here implicitly, so I've moved every variable to the left side and set the equation equal to 0. You can see on the right that we have our graph, and the parabola, I'm going to move it this way. You can see the parabola is on the xy plane, and that trace does not change, so it gets repeated so here's the parabola that gets repeated along the z-axis. So this runs, there's our z-axis, and so this parabola, we say it runs parallel, the cylinder runs parallel to the z-axis, and it's a parabolic cylinder because the trace is a parabola. So that's our first cylinder. Cylinders do not have to have a circular base, but they can. Let's take a look at a second example. In the example in number 2 that I have here, we have an equation with two variables in R3. So notice that the missing variable here is y. So that means that this cylinder will run parallel or along the y-axis because that is the missing variable. So y can take on any values from negative infinity to infinity. It's not restricted by the equation. I'm going to write this equation in standard form so that this 36 is a 1, and we can determine what conic section we have on the xz plane. So dividing every term by 36, we're going to get x squared over 4, because that goes into 36 4 times, plus z squared over 9, because 4 goes into 36 9 times, is equal to 1. So here I divided the equation. Let me rewrite that. Divide each term by 36. And we have here, this is an ellipse in standard form, and this ellipse can be thought of on the xz plane, but also that's when y is 0, but also we will have the same trace no matter what value of y we take on. So if I just sketch the trace on the xz plane, I'm just going to sketch the trace here, and then we will look below for the actual graph of this cylinder. So this is I'm going to label the vertical axis as the z-axis, the horizontal axis as our x-axis, and because our standard form of the ellipse is x squared over 4, that means that along the x-axis we're going to go 2 units to the right and 2 units to the left to get the intercepts on the x-axis. And the z squared over 9 means we go 3 units up and 3 units down to get the intercepts along the z-axis. And that's going to give us an ellipse, which is the trace on the xz plane. But not only on the xz plane, it gets repeated for any value of y. So if I were to think about what this could look like in space, I'm going to do a very small graph here, and then we'll look at CalPlot 3D once more. On the xz axis, we have an ellipse that looks like this, and that trace gets repeated for any value of y. So this is going to run parallel to the y-axis or along that y-axis, and we're going to have an elliptical cylinder that looks something like this. Let's take a look at it on CalPlot 3D. And what I want to show you here is the way that I've set this up is I have the y-axis here running vertically. So you can see that the trace of the ellipse on the xz plane at the bottom here gets repeated along the y-axis. So the y-axis is what this cylinder runs parallel to. And the trace is on the xz plane, and that trace gets repeated. So there we have our elliptical cylinder that runs along the y-axis. You can see it again here, where we have the y-axis running in this direction, and the trace of the ellipse is getting repeated for any value of y. So just to summarize, cylinders always run parallel to the axis of the missing variable. The equation of a cylinder in space always has only 2 variables, and the cylinder runs parallel to the axis of that missing variable. I know I've repeated myself, but I want to make those points clear. The trace never changes along that axis.